25 in the non-stone formers. So there really isn't an absolute upper limit of metastability in dogs or cats or humans. It is dependent upon, are you a stone former or not? And people and dogs and cats who tend to form stones typically have a lower limit and so are more likely to form stones. So what are the key points of this so far? Urine supersaturation is necessary for stone formation. The relative supersaturation and the activity product ratio are both estimates of urinary saturation. The activity product ratio gives additional information in that it indirectly measures the inhibitory capacity of the urine. The metastable range is the point of supersaturation, above the saturation point, above the solubility product, where the urine struggles to hold those solid minerals in solution. It's the zone between the solubility product and the formation product. For stones to form, then, either you must exceed the formation product or you lower the formation product. The other thing to keep in mind is, although there are numbers available, 10, 12, 14 for calcium oxalate, when relative supersaturation and activity product ratios are determined, they actually do not give that number. It is not possible from those techniques to determine the upper limit of metastability, the heterogeneous formation product. What separates a stone former from a non-stone former? Now, how have urine saturation estimates been used, though? And I will just give some examples, not the entire literature. It has been used to evaluate the influence of diets in healthy cats and dogs. That is, you can feed different diets to healthy cats and measure urine saturation and compare which ones result in lower saturations for, say, calcium oxalate on the left or struvite on the right. It has been used by pet food companies to formulate diets to help with the management of stone types. For example, the Purina veterinary diet UR-STOX. When formulating such a diet, it is important to keep the urine undersaturated for struvite and to achieve the lowest level of saturation for calcium oxalate. The lower the number, the better it is in decreasing the risk of stone formation. So with both canned and dry and with both techniques, the numbers generated are near 1, near the point of saturation, at the lower end of the metastable range, where minerals are held in solution and new crystals do not form. Likewise, it's been shown with that diet to keep the urine saturation for struvite less than 1, in the undersaturated range. New crystals do not form, stones do not form. Any crystals that even form dissolve. Any stones that would be present in an undersaturated urine would dissolve. It's been used to evaluate the influence of diet formulation and diet ingredients. This is a study evaluating the influence of an acidifier, ammonium chloride, and an alkalinizing agent, sodium bicarbonate, in healthy cats. The pHs are, of course, different between those two treatments and the control diet, but as you acidify the urine with ammonium chloride, the relative saturation for calcium oxalate increases. It increases above 1. It takes it from a state of undersaturation into a supersaturated state. Likewise, giving an acidifier increases the amount of calcium that's excreted in the urine. It therefore increases the risk of calcium oxalate stone formation. And in healthy cats even, it decreases the citrate excretion. And citrate is an inhibitor of calcium oxalate formation. So not only does it increase the amount of calcium available, it decreases the urine's ability to prevent crystals from forming. We've also shown that that's true just as a pH effect. In healthy cats fed 3 different diets, maintaining 3 different urine pHs. The higher the urine pH, the lower the saturation for calcium oxalate. It has been used to evaluate the influence of sodium on urine saturation, which again is a risk for stone formation. Diluting the urine is one way to help prevent stones from forming. That can be accomplished by feeding a canned diet or by stimulating the cat to drink more water. Again, using the Purina, the UR diet, increasing the sodium content to 1.2% resulted in lower degrees of saturation for both calcium oxalate and struvite. These are the struvite data. And these are the calcium oxalate data. Increasing urine volume is a way to lower the degree of urine saturation. It can be used to evaluate other non-dietary treatments. In humans, hydrochlorothiazide, a distal tubular diuretic, is used to treat calcium oxalate stones. We've shown again in healthy cats that in combination with an oxalate preventative diet, administering hydrochlorothiazide induces or results in a degree of lower saturation. In fact, for calcium oxalate on the bottom right, a degree of undersaturation. We've evaluated glycosaminoglycans, which are also an inhibitor of calcium oxalate formation, and actually administering glycosaminoglycans does lower the degree of saturation for calcium oxalate without increasing the risk of struvite. We've even used these techniques to evaluate non-traditional treatments, such as traditional Chinese herbs, looking at alisma and some other herbal compounds, which neither increase nor decrease the risk for calcium oxalate or stone formation. There is one study that's actually compared urine saturation with in cats that had previously formed calcium oxalate stones. In this study, cats who had formed stones, calcium oxalate stones, were evaluated either when they were consuming the diet on which they formed the stones, shown in green, or on an oxalate preventative diet, shown in yellow. The relative supersaturation and the activity product ratios for calcium oxalate were statistically significantly, clinically, lower when consuming the oxalate preventative diet. But what we are lacking in terms of feline medicine is that we do not have information as to how do these estimates of saturation compare with a recurrence rate of stone disease. In fact, there is only one diet that has been evaluated in dogs that determined a benefit by evaluating dogs who had recurrent stone disease, and it lowered recurrence rates by half. So what does the future hold? First, we need to validate that urine saturation is not only useful in formulating diets, but actually is useful in predicting stone recurrence or not. That they can be used to dissolve stones, that we know. But do they prevent, especially calcium oxalate stones, from coming back? The hard endpoint, do stones recur or not? It would be nice to have larger studies than comparing urine chemistry values and saturation between stone-forming animals and non-stone formings. We have used a technique, and others have used a technique, to evaluate other stone types in other species. So it has application beyond dogs and cats and humans. We've looked at it in giraffes, in wild cats. We've looked at cysteine, ammonium urate. It would also be nice in the future, and some of the work that we and others are doing, is to look at other risk factors for stone formation, the inhibitory capacity, other pharmacologic treatments. In fact, the only study done in dogs or cats is this study that looked at urinary inhibitors in Dalmatians who form urate stones. And it was found that TAM horsefall protein and glycosaminoglycans that are inhibitors of ammonium urate formation were lower in the stone-forming Dalmatians than in the non-stone-forming Dalmatians. This has not been evaluated yet in cats. So in summary, the estimates of urinary saturation are in fact very useful. Many companies use relative supersaturation, but others also use activity product ratios. They both give measures of urine supersaturation, but they give different results and are performed differently. The estimates of urinary saturation do not actually give the upper limit of metastability, that point of heterogeneous nucleation. That has to be determined by another technique. Urine saturation studies estimate the major but not only risk factor for stone formation. They are a good starting point for formulating diets that help minimize, especially in cats, help minimize the risk of struvite and calcium oxalate stone formation. They can be used to evaluate treatments. Keep in mind, though, that urine saturation is not the only risk factor, but using dietary therapy first has been shown to decrease the degree of urine saturation and therefore decrease the risk of stone formation. And it would be nice in the future to prove that by comparing these numbers with actual stone recurrence data. In the oxalate and stone preventative diets such as Purina UR, you can formulate diets that minimize two different stone types. They have been shown, at least in healthy animals, to decrease the degree of supersaturation for calcium oxalate without increasing the supersaturation for struvite, meaning they decrease the risk for calcium oxalate stone formation without increasing the risk for struvite stone formation. That benefit is well beyond a pH effect or a specific nutrient effect or the magnesium level. Urine saturation studies take into account all of these variables, and activity product ratios take into account things that we do not even measure. And this cartoon says, sorry, at the veterinary office, the dog says, sorry, I kept missing the cup. And with that, I appreciate and thank you for attending tonight and for listening to 40 minutes of urine saturation. I also thank Nestle Purina for inviting me, and again to Christian and to Clementine for hosting us. I especially want to thank the interpreters who had to try and interpret my southern accent. And most importantly, again, thank you for giving up a night and come to listen to not only me, but the other speakers. Thank you.